ഹായ് വെൽക്കം ടു കോമ്പറ്റേറ്റീവ് ക്രാക്കർ. എല്ലാവർക്കും സ്വാഗതം. അപ്പോൾ നമ്മൾ ഇന്ന് പ്രത്യേകം വന്നിരിക്കുന്നത് നമ്മുടെ റിപ്പീറ്റേഴ്സും ഫ്രഷേഴ്സുമായിട്ട് ഇനി അടുത്ത CSIR ഫിസിക്സ് പരീക്ഷ എഴുതാൻ പോകുന്ന എല്ലാ ആൾക്കാരെയും ഉദ്ദേശിച്ചുകൊണ്ടാണ്. അപ്പോൾ ഇന്നത്തെ നമ്മുടെ പ്രധാനപ്പെട്ട ഒരു അജണ്ട എന്ന് പറയുന്നത് നമ്മുടെ അടുത്ത ജൂണിലെ CSIR ഫിസിക്സ് എക്സാം ഏത് രീതിയിൽ നമുക്ക് പ്രിപ്പയർ ചെയ്യണം, എങ്ങനെയായിരിക്കണം നമ്മുടെ പ്രിപ്പറേഷൻ സ്ട്രാറ്റജി, അങ്ങനെയുള്ള കാര്യങ്ങളെ ഡിസ്കസ് ചെയ്യാനും നമ്മുടെ പ്രധാനപ്പെട്ട പേപ്പറുകൾ എങ്ങനെയായിരിക്കണം നിങ്ങൾ പ്രിപ്പയർ ചെയ്യേണ്ടത് എന്നിങ്ങനെയുള്ള കാര്യങ്ങൾ ഡിസ്കസ് ചെയ്യാൻ വേണ്ടിയിട്ടാണ് നമ്മുടെ ഇന്നത്തെ ഈ ഒരു സെഷൻ. അപ്പോൾ ഈ സെഷൻ്റെ ആക്റ്റീവ് പാർട്ടിസിപ്പേഷൻ ഞാൻ എല്ലാവരിൽ നിന്നും പ്രതീക്ഷിക്കുന്നു. അപ്പോൾ നിങ്ങളെല്ലാവരും നന്നായിട്ട് ശ്രദ്ധിക്കുക. നമ്മൾ എങ്ങനെ വേണം പഠിച്ചു തുടങ്ങാൻ എന്നുള്ള കാര്യങ്ങളെ പറ്റി നമ്മൾ ഡിസ്കസ് ചെയ്യുന്നത്, അതിൻ്റെ സംശയങ്ങളെല്ലാം കൃത്യമായിട്ട് ചോദിക്കുക. അപ്പോൾ ഈ ഒരു സെഷനോട് കൂടി നമ്മുടെ അടുത്ത നെറ്റ് പരീക്ഷയ്ക്ക് വേണ്ടിയുള്ള നമ്മുടെ പ്രിപ്പറേഷൻ കിക്ക് സ്റ്റാർട്ട് ചെയ്യാനായിട്ട് നമുക്ക് സാധിക്കണം. സോ ഇന്നത്തെ വെബിനാർ നമ്മുടെ പ്രധാനപ്പെട്ട ഒബ്ജക്റ്റീവ്സ്, സോ എക്സാം സ്ട്രക്ചർ മനസ്സിലാക്കുക, അതിൻ്റെ പ്രിപ്പറേഷൻ സ്ട്രാറ്റജീസിനെ പറ്റി ഡിസ്കസ് ചെയ്യുക. സോ ബിഗിനേഴ്സ് എന്ത് ചെയ്യണം, റിപ്പീറ്റേഴ്സ് എന്ത് ചെയ്യണം എന്നിങ്ങനെയുള്ള കാര്യങ്ങൾ ഡിസ്കസ് ചെയ്യുക. ദെൻ അതിൻ്റെ പ്രിപ്പറേഷൻ ട്രിക്കുകൾ എന്തൊക്കെയായിരിക്കണം എന്നുള്ള കാര്യങ്ങൾ ഡിസ്കസ് ചെയ്യുക എന്നതൊക്കെയാണ് നമ്മുടെ ഇന്നത്തെ പ്രധാനപ്പെട്ട അജണ്ട എന്ന് പറയുന്നത്. സോ അപ്പോൾ നിങ്ങൾക്കറിയാം നമ്മുടെ CSIR നെറ്റ് ഫിസിക്സ് എക്സാം ഇനി നടക്കാൻ പോകുന്നത് ജൂണിലായിരിക്കും. മോസ്റ്റ് പ്രോബബിളി അത് ജൂണിലെ തേർഡ് വീക്ക് അല്ലെങ്കിൽ സെക്കൻഡ് വീക്കിൽ തന്നെയായിരിക്കും. തേർഡ് വീക്കിലായിരിക്കും മോസ്റ്റ് പ്രോബബിളി എക്സാം ഉണ്ടാവുക. സോ ഇതിന്റെ ഒരു നെറ്റ് എന്ന് പറയുന്നത് നിങ്ങൾക്കറിയാം, ഇറ്റ് ഈസ് പ്യുവർലി ഇറ്റ് ഈസ് എ കോൺസെപ്റ്റ് ബേസ്ഡ് എക്സാം ആണ്. സോ അതൊരു കോൺസെപ്റ്റ് ബേസ്ഡ് എക്സാം ആയതുകൊണ്ട് തന്നെ അത് നമ്മൾ ഈ പഠിക്കുന്ന എന്താണ് മെമ്മറൈസ് ചെയ്യുന്ന കാര്യങ്ങളോ അങ്ങനത്തെ കാര്യങ്ങളൊന്നും ആയിരിക്കില്ല നമുക്ക് ഇതിനകത്ത് നിന്ന് ചോദിക്കുക. സോ കോൺസെപ്റ്റുകൾ നിങ്ങൾക്ക് മനസ്സിലാവുന്നുണ്ടോ ഇല്ലയോ എന്നുള്ളതിനെ ബേസ് ചെയ്തായിരിക്കും നമ്മുടെ എക്സാം. സോ അതിന്റെ പ്രധാനപ്പെട്ട കീ പോയിന്റ് എന്ന് പറയുന്നത് നമുക്ക് ഒരു പ്രോപ്പർ ആയിട്ടുള്ള സ്ട്രാറ്റജി ഉണ്ടാവണം, പ്ലസ് ഫിസിക്സ് നോളജും നമുക്ക് ഉണ്ടാവണം. സോ ഈ രണ്ട് കാര്യങ്ങളും കൂടി ചേരുമ്പോഴായിരിക്കും നമുക്ക് അടുത്ത എക്സാമിന് വേണ്ടി നമുക്ക് വിജയിക്കാനായിട്ട് സാധിക്കുക. സോ ഇവിടെ ഞാൻ നേരത്തെ പറഞ്ഞതുപോലെ മെമ്മറൈസ് ചെയ്യുന്നത് കൊണ്ട് നമുക്ക് പ്രത്യേകിച്ച് ഒരു ഗുണവുമില്ല. മെമ്മറൈസ് ചെയ്യുക എന്ന് പറഞ്ഞാൽ നമ്മൾ ഓരോ പ്രോബ്ലംസ് കാണാൻ പഠിക്കുക, അല്ലെങ്കിൽ കുറെ ഡെഫിനിഷൻസ് കാണാൻ പഠിക്കുക. നമ്മൾ PGക്കൊക്കെ പഠിക്കുന്നത് പോലെ കുറെ എന്താണ് കുറെ കാര്യങ്ങൾ. ഓ യെസ്, ഐ ക്യാൻ എക്സ്പ്ലെയിൻ ഇൻ ഇംഗ്ലീഷ്, ഷുവർ. So the things are not about clearly memorizing these all things or simply mugging up things won't do anything for the CSIR exam. That means just like that what we are doing for PG. For PG we just mug up some things. Just we will memorize some derivations, we will memorize some equations without knowing anything about the background. Like, so we are not bothered about the background. We just memorize the things. We just go and we will just write down what all things we know, and we will get some marks and we will get satisfied. So that is not the thing that we aim in CSIR net. So the thing is, we must have a proper conceptual knowledge, and also we should have a smart question selection. So it is all about leaving the question, smartly leaving the question that we don't know. So we don't have to answer 75 out of 75 questions appearing for this CSIR examination. So we have to select smartly. So in the part A, we only have to answer 15 questions. In part B, we have to answer only 20 questions. In part B, we have to answer about 20 questions. So it's all about answering these questions. So we have to select the questions accordingly in such a way that we must not get any negative marks. Okay, so we have to get rid of the negative marks. Some people may get some may get marks which are equivalent to their qualifying cutoff, but the thing is their negative marks will spoil their results. That is the thing. So we have to select the question in such a way that we have to eliminate the risk of negative marks. I hope it is clear. So this is the exam pattern. So part A, it is about the general aptitude and all research aptitude. Then part B, it is a conceptual physics. And part C, it is very, very important. It is analytical problems. So part B is all about analytical problems, and we have to focus our preparation based on these analytical problems or based on part C. So we should not focus on part B. We should focus on part C. Then part B will automatically follow. So we should prepare all the questions, or we should prepare all the units so as to answer part C. So you have to be very knowledgeable about all the units, so that we should be able to answer all the questions in an analytical level, in a research level. Okay, so negative marking matters. So that is very crucial. You should not get any negative marks. We should get all the marks that we have earned. Okay, so our negative marks should not take away unnecessarily the marks that we have scored. So you should leave the question. You should select the question. Clear. So this is the general exam pattern. So you should prepare separately for part A and part B and C. So you can prepare for part B and C together, and part A you should prepare separately. So you should have better mathematical reasoning. You should prepare well for mathematical reasoning. You should prepare well for general aptitude or research aptitude, and also for logic, for logical level questions. So without preparation, you cannot answer part A. Okay, so that is very, very important. Then, so this is the importance of part A. So part A is it is not a silly matter. So we should prepare for part A, and part A can decide whether we are eligible for JRF, or whether we are eligible only for lectureship, or whether we are eligible for the third class, that is admission for PhD only. So even a single mark will decide our fate. So you should seriously prepare for part A also. So it is compared to part B and C, it is easily scorable part. So it is easily scorable with practice only. So we should dedicate some time for part A questions also, practicing part A questions also. Okay, so mathematical reasoning is very, very important in the part A, and you should regularly practice. So we should not skip our studies of part A until the last. So if you start preparation for part A from the very beginning, it will definitely help you to answer it very easily. So that during our last phase of revision, you can focus more on part B and C. There you can neglect part A because you already have completed your practice based on part A. Okay, so you should prepare part A from the very beginning itself. So you should regularly practice part A. So 30 minutes of preparation daily will definitely help to score better marks in part A. So you should not ignore part A. The part A is very, very important for easily getting some marks. We can definitely get 15 or 20 marks, in the range of 15 or 20 marks. So you should aim for 15 or 20 marks in part A, not or 30 out of 30, but you should aim for 15 to 20 marks in part A. Hope it is clear. Then, so part B versus part C. So what about part B? Part B is regarding conceptual clarity, and it is comparably faster questions. So you can answer it a bit more faster compared to part C. So you can go through the syllabus. Hope you have seen the syllabus. So in the syllabus, part B is there, part A is there, part B is there. Part A in the questions from part A of the syllabus will come in part B, and questions from part B of the syllabus will come in the part C. So part B is comparatively easier, but we should not restrict our studies for part B only. So we should prepare, or we should aim for part C questions. Part C ആയിരിക്കണം നമ്മുടെ ബേസ്. പാർട്ട് സിയെ ബേസ് ചെയ്തിട്ട് വേണം നമ്മൾ പഠിക്കാൻ. So we should work from the basis of part C. Okay, so basis of analytical question. You should focus on analytical question from every unit, from starting from mathematical physics to electronics. അപ്പോൾ ആ ഒരു ലെവലിലായിരിക്കണം നമ്മുടെ പ്രിപ്പറേഷൻ. Then what about part C? So part C question is regarding deep analytical level question. So the question will not be direct. The question will not be about given a formula. You have to substitute some values which are given in the question and you will get the answer. No, it won't be like that. So it will be a mixing of questions will be there. It will be multi-step problems will be there. So so it is a part C that decides our future. So if you are able to get about 60 to 70 marks in part C, definitely your result will come in the category of JRF. So we should aim for 70 marks or 70, 75 marks, 60 to 75 marks in part C. Then the rest 60 marks you can score from part A and part B. Then you will be safe. Okay, so 70 to 75 marks must be our aim from part C. So you should prepare very deeply. You should have a better understanding about the physics part from all the units that you are given. So അത്ര ഡീപ്പായിട്ട് ഫിസിക്സ് അറിഞ്ഞാൽ മാത്രമേ നമുക്ക് പാർട്ട് സി ആൻസർ ചെയ്യാൻ പറ്റുള്ളൂ. സോ you should prepare accordingly. Clear? So I hope that is also very clear. So if you have any questions in between, you can ask. My chat box is open. So you can pose any questions if you have. Okay, I will definitely answer. Then these are some of the common mistakes by the aspirants that I have noted. So the main thing, the important thing, which may appear strange to most of us, is trying to study everything. So as a CSIR aspirant, as a CSIR student, we are focusing to study each and everything which is given in the syllabus. No, it should not be in such a way that you have to study each and everything which is given in the syllabus, each word. No, you should focus on you should select the topics which are suited to you. Okay, so ഇതെല്ലാം പഠിച്ചിട്ട് പോയി എക്സാം എഴുതുക എന്ന് പറയുന്നത് it is practically impossible. It is impossible because you are studying the things which you have studied for 2 years in your MSc or PG. So you are studying it within 6 months of span. So if you are if you are what constraining everything into 6 months, the 2 year syllabus has been shortened to 6 months. So it is humanly impossible to study each and everything. So you should select. So the thing is, if the students are going to select, it will be a tremendous effort. They should have some tremendous effort. They should put some tremendous effort for that, or they will end up in nothing. So there comes the need of coaching. So or there comes the need help the help from experts. So അങ്ങനെ ഒരു എക്സ്പേർട്ടിന്റെ ഹെൽപ്പ് ഉണ്ടെങ്കിൽ നിങ്ങൾക്ക് ഇങ്ങനെ സെലക്ഷൻ സ്മാർട്ട് സെലക്ഷൻ ഇറ്റ് വിൽ ബി ഈസി. അപ്പോൾ അങ്ങനെ ഒരു സെലക്ഷൻ നടക്കുകയാണെങ്കിൽ നിങ്ങൾക്ക് ഏതൊക്കെ ഭാഗങ്ങൾ പഠിക്കണം, വി വിൽ ഗിവ് യു ഓർ വി വിൽ സെലക്ട് ഫോർ യു. സോ ഞങ്ങൾ പഠിപ്പിക്കുന്ന കാര്യങ്ങൾ നിങ്ങൾ അതുപോലെ പഠിക്കുകയാണെങ്കിൽ സോ നിങ്ങൾക്ക് ദെൻ the things will be easy for you. സോ ആ ഒരു കാര്യം നിങ്ങൾ ചിന്തിക്കണം. എപ്പോഴും എല്ലാ കാര്യങ്ങളും പഠിച്ചിട്ട് ഇത്ര വലിയൊരു എക്സാമിന് പോകുക എന്ന് പറയുന്നത് ഇറ്റ് ഈസ് ഇമ്പോസിബിൾ. സോ യു ഷുഡ് സെലക്ട് ദ ടോപ്പിക്സ് വൈസ്ലി. സോ അത് എങ്ങനെ ചെയ്യണം, ഹൗ ടു സെലക്ട് ടോപ്പിക്സ്, വി വിൽ ഡിസ്കസ് ഇൻ ഡ്യൂ കോഴ്സ് ഓഫ് ടൈം. സോ then the second mistake is you are ignoring strong topics. So I have told you you should not study everything. Then what will you do? You will cut off some topics which are difficult for you. Then you will be cutting off the strong topics which are more probable to be asked in the CSIR examination. So uh, that is a foolish decision. That will end up as a foolish decision. So ignoring strong topics അതൊരു വലിയ തെറ്റ് തന്നെയാണ്. ഇപ്പം നിങ്ങൾ for example, if you are ignoring the probability theory, or if you are ignoring some complex analysis topics from mathematical physics, so that is a fatal. There will be some 3 or 4 questions from mathematical this complex analysis each and every year. So so if you are ignoring those topics, if നിങ്ങളത് പഠിക്കുവാണെങ്കിൽ it is easy that you can score from these complex analysis, and if you are ignoring it, then definitely your answer for your correct എന്താണ് അത്രയും മാർക്കുകൾ നിങ്ങൾക്ക് നഷ്ടപ്പെടുകയാണ്. അത്രയും ഷുവറായിട്ടുള്ള 4 ക്വസ്റ്റ്യന്റെ മാർക്കുകൾ നിങ്ങൾക്ക് നഷ്ടപ്പെടുകയാണ് ചെയ്യുന്നത്. സോ യു ഷുഡ് സെലക്ട് ദ ടോപ്പിക്സ് വൈസ്ലി വിതൗട്ട് ഇഗ്നോറിംഗ് സ്ട്രോങ് ടോപ്പിക്സ് ഓർ ഹോട്ട് topics. Okay, so then the fear of part C. So most of us will be fond of part A, will be somewhat we will be liking part B, and will be definitely afraid of part C. So ഇതാണ് എല്ലാവരുടെയും ഒരു ജാതകം. So this is common for all. സോ പാർട്ട് സി നമ്മൾ ഏറ്റവും ലാസ്റ്റ് നമ്മൾ ഇഗ്നോർ ചെയ്ത്, നമ്മൾ പേടി കൊണ്ട് ഇഗ്നോർ ചെയ്ത് ക്വസ്റ്റ്യൻ ചെയ്യുന്ന ഒരു ഭാഗമാണ് പാർട്ട് സി. സോ ദ ഫിയർ ഓഫ് പാർട്ട് സി വിൽ definitely take away CSIR from you. So the fear of part C should be taken away from you. ഓക്കെ, ആ ഒരു ഭയം നിങ്ങളിൽ നിന്ന് എടുത്തു മാറ്റപ്പെടണം. എങ്കിൽ മാത്രമേ നിങ്ങൾക്ക് നല്ല രീതിയിൽ പ്രിപ്പറേഷൻ നടക്കൂ, എക്സാം പാസ് ആവാനും പറ്റൂ. ദെൻ ഓവർ അറ്റംപ്റ്റിംഗ്. Then for examination, you will be aiming to answer all 75 questions, or all 20 questions from part C, all 20 questions from part B, all 15 questions from part A. So, have anyone asked you to solve all these questions? No, no one has asked you. So you are over attempting each and every question. No, you should select the topics, and you should answer the questions, or you should select the topics, or you should answer these questions wisely only. Okay, so അല്ലാതെ നിങ്ങൾ ഈ എല്ലാ ക്വസ്റ്റ്യനെയും കയറി ആൻസർ ചെയ്യാൻ പോയാൽ നമ്മൾ നമ്മൾ പറയാറുണ്ട്, വഴിയെ പോകുന്ന എല്ലാ നായ്ക്കൾക്കും കല്ലെറിയരുതെന്ന് പറയാറുണ്ട്. സോ ദാറ്റ് വിൽ നോട്ട് റിസൾട്ട് ഇൻ proper success. So over attempting is another mistake. So these are the 4 mistakes. So ഈ 4 മിസ്റ്റേക്കുകളും you should you should avoid these 4 mistakes. How? By practice only. So you should practice. So how you can practice? By writing examinations. So so you are getting weekly 2 examinations at competitive cracker. So രണ്ട് എക്സാം വെച്ച് നിങ്ങൾ എഴുതുമ്പോൾ you will definitely get rid of these 4 mistakes. So definitely you will be liking part C, and you will be able to, you will study to learn the topics in the required manner. Okay, and required gravity നിങ്ങൾ പഠിക്കേണ്ടത് നിങ്ങൾ പഠിക്കേണ്ടി വരും. So so Reshma has asked, is there any minimum number of questions to attempt from each part? Yes, there is a minimum number, and if you are answering more than that minimum number, they will select the first 15. So you will be you are required to answer 15 questions from part A, 20 questions from part B, and 20 from part C. So if you are answering 20 questions from part A, suppose you are answering 20 questions from part A, the machine will select the first 15. The machine will ignore the last 5. So you should answer only 15 questions. Okay, so in the first 15, if the 10 are wrong, then the 10 negatives will be added to your answer. Okay, so your marks. Okay, so there will be there are minimum required number, and that number should only be answered. Okay, if you are attending more than question, more than the required number, the first 15 or first 20 will be selected for evaluation. Okay, I hope it is clear, Reshmi. Then this is a strategy for beginners. So definitely in June 2026, some beginners will be attempting the examination for the first time. So you should focus on fundamentals. So what are those fundamentals? So you should focus on the fundamental topics and fundamentals from each and every part. Okay, so you should answer the questions based on these fundamentals. So I always insist on stick on to the basics and answer the question. Try to read the question by sticking on to the basics. So there are some basic strategies for each and every core topics. So which we will be discussing. So assistant professor notification ഏത് മന്ത് കാണും. സോ അത് അസിസ്റ്റന്റ് പ്രൊഫസർ നോട്ടിഫിക്കേഷൻ ഇപ്പോൾ 2021 എക്സാം കഴിഞ്ഞ് 2023 ലിസ്റ്റ് വന്നിട്ടുണ്ട്. സോ ഇപ്പോൾ ഏത് സമയത്ത് വേണമെങ്കിലും 2026 എപ്പോൾ വേണമെങ്കിലും ബൈ ജൂൺ നമുക്ക് എക്സ്പെക്ട് ചെയ്യാം. ഓക്കെ, you should focus on fundamentals. So you should first study the core subjects. So which are the core subjects? I hope you know: mathematical physics, quantum mechanics, classical mechanics, electromagnetic theory, then electromagnetic theory and statistical mechanics and thermodynamics. These are the core subjects. So you should focus on these core subjects. You should study the core subjects first, not you then. So you should then focus on the other topics like solid state physics, atomic and molecular physics, then electronics, and such other topics, nuclear physics, etc. So is there negative mark for those questions attended more than required number? No, 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 there will not be any negative marks. There will not be any negative marks. The only thing is that the system will select only the first 15 or first 20. Okay, so we should we should have better understanding about the question, what all questions that we are answering. Okay, so if you are sure about the last 5, you should answer the last 5 and then go for the selection for the first 10. I hope you have understood. Now the system now the system may be blocking, but uh, I think the CSIR has a plan to lift that up. So the system will not be blocking you. You will be free to attempt any question, any number of questions. The CSIR is going to. I have heard from my professor. So CSIR is going to think like that, so that it will impart more competitive attitude or more competition among the aspirants. If the system is blocking you from over attempting the question, the negative marks, that means you are the system itself is restricting you from getting more negative marks. So that provision is going to be lifted up, I think. So this is a strategy. So you should start part C slowly. So from the very beginning, from the first day onwards, you should not go for studying part C questions. No, നിങ്ങൾ അങ്ങനെ പഠിക്കാൻ പോയി കഴിഞ്ഞാൽ ആദ്യത്തെ ദിവസം തന്നെ നിങ്ങൾ ഇട്ടിട്ട് ഓടും. So you will definitely run away. So you should focus on part B question first for first few weeks. Then go for part C. So you should start studying from mathematical physics. And the fourth point is very, very important. You should be very consistent in solving problems. So for our normal PG course, we are not familiar with solving problems, right? So we are not solving any problems. We are just practicing essays. So this is not the thing for CSIR. You should be very familiar with problem solving. So you should consistently solve problems. Okay, you should know how to solve a problem. You should know how to solve an unfamiliar problem. That is a very, very important point. So you should study to how to do problems. So that is the core point that I want to stress on. So practice more problems. So the only thing that you should do is practice, practice, and practice. Daily do problem solving practice. Okay, that will definitely help you in one way or the other. So this is the strategy for beginners. Then so this is the suggested subject order. First you should study mathematical physics, then you should study classical mechanics, then go for quantum mechanics, then go for electromagnetic theory, then statistical mechanics, then solid state physics, then go for nuclear, and then atomic, and then electronics. Okay, so this is the subject order. Then the thing is that you should not aim to study these subjects sequentially. So you should simultaneously study some two subjects. You can club two subjects. For example, first you may go for mathematical physics alone. So mathematical physics, I have given some nicknames for these mathematical core subjects. So you should study mathematical physics. Then you can club classical and quantum. You can study parallelly or simultaneously. So if you are aiming to study these papers sequentially, we will not get sufficient time. So some of the papers that you will have to study parallelly. So mathematical physics should be studied alone. Then classical and quantum could be studied parallelly. Then electromagnetic theory and statistical mechanics could be run parallelly. Then solid state and atomic and molecular physics could be studied parallelly. Nuclear and electronics could be run parallelly. So this should be the strategy for repeaters and for freshers. Okay. So the only subject which could not be clubbed with anyone, it is mathematical physics. Why? Because mathematical physics is the base of everything. So if you are well equipped with mathematical physics, then everything will be easy. Okay. So first you should focus for mathematical physics. I hope the subject order and the combination is also very clear to you. Clear. Then, so before going into anything, see our JRF Victory Batch admission is going on, and if you wish to join our batch, you can contact the number which is given. I think I hope the Google form is also attached in the description. So yes, the Google form is also attached in the description. You can register in the Google form to get the course offers, or you can contact in the board number. So our admission is going on, and we are our timetable wise studies has started already started, and our live class will start within 2 or 3 days. So before our live class begin, I invite everyone to join our CSIR Net Physics journey so that we can study together. So uh, so I invite or I welcome you all, competitive cracker. Then so mathematical physics. So mathematical physics is the backbone of a CSIR net physics. So it is the backbone. So this is what I do for each and every paper. So what CSIR tests in mathematical physics? So CSIR tests your application, not derivations. So application level questions will be given to you. So vector calculus, everything. So then uh, your speed and familiarity with the topic will be tested. And mathematical physics is the tool to solve problems in all other subjects. So there is sometimes, for example, our see Fourier transform and our Laplace transform problems. So those problems will not be asked from mathematical physics. They will be asked from scattering theory. Laplace transform and scattering theory both are the scattering theory problems could be done by using this Laplace transform very easily. So they will club mathematical physics problems with other papers. So it acts as a tool to solve problems from other papers also. So this is what CSIR tests you from mathematical physics. So the high scoring topics from mathematical physics are given here. So it's a linear algebra. So eigenvalues, eigenvectors, matrices, how to find eigenvalues, how to diagonalize a matrix, and all those things. Cayley-Hamilton theorem, its applications, all those things. Then comes vector calculus, divergence, gradient, curl, vector integration, so all those things. Then comes hot topic complex analysis. Complex analysis is very very important. Cauchy integral theorem, residues, then Cauchy-Riemann conditions, all those things. Then comes Fourier and Laplace transforms. Then ordinary differential equations, partial differential equations. Then special functions, Legendre, Bessel, Lagrange, Hermite, etc. Their properties. So these are the high scoring topics from mathematical physics. Okay. So I have divided the strategy for beginners and repeaters for mathematical physics. So for beginners, you should do problem oriented study. So we will be more lenient towards the proofs which are more familiar for us while we study our PGs. അല്ലെ, നമ്മൾ PG പഠിക്കുന്ന കാലത്ത് കൂടുതൽ പ്രൂഫ് ചെയ്യുന്നതുകൊണ്ട് വിൽ ബി lenient towards that. No, you should do problem oriented studies. Then you should learn when to diagonalize symmetrics, when to use symmetry properties, and so on. Then you should practice problems daily from mathematical physics. That is very crucial. Then you can use mathematical physics along with quantum mechanics, electromagnetic theory, because electromagnetic theory and vector calculus both are tightly bonded. Quantum mechanics, integration, then Fourier transform, Laplace transforms, all those transforms, the differential equations, all those are very tightly bounded. So you can study mathematical physics along with quantum mechanics and electromagnetic theory also. Okay, then for repeaters, you should improve your speed and confidence. So the speed is very crucial, because if you save some time from one problem, you can apply it for another problem which is difficult or which is more indirect. So you should improve your speed, and you should improve your confidence in doing the problems from mathematical physics. Okay, then you should memorize the standard results. It is common for both repeaters and freshers. So standard results should be memorized. So Jacobians, common integrals, all those things. Then you should practice CSIR style mixed problems. That's what I aim. So mixed problems, just as what I said from the scattering theory. Then from classical mechanics, by from different applications of differential equation, you will be asked to calculate the solution for the Lagrange's equation, or Hamilton's equations of motion, the solutions of that. So they are testing whether you know to solve differential equations. So there are different differential equations, different styles of differential equations are also there. Then you should reduce calculation errors. That's very, very important. So calculation errors. So നമ്മളെല്ലാവരും പഠിക്കൽ കൊണ്ടുപോയി കലവടയ്ക്കുന്നവരാണ്. So calculation error നിങ്ങൾ കുറയ്ക്കണം. So it is not suited for repeaters. So for freshers, I can understand that they will make mistakes here and there. But for repeaters, അത് ക്ഷമിക്കാനാവാത്ത തെറ്റാണ്. സോ നിങ്ങൾ കാൽക്കുലേഷൻ എററുകൾ പരമാവധി റെഡ്യൂസ് ചെയ്യുക. I hope this is clear. So for mathematical physics, what these are the common mistakes. So spending weeks on rigor. So നിങ്ങൾ മാത്തമാറ്റിക്കൽ ഫിസിക്സ് പഠിക്കുകയാണെന്ന് കരുതി ആഴ്ചകളോ മാസങ്ങളോ വർഷങ്ങളോ അതിനു വേണ്ടി എടുക്കേണ്ട കാര്യമില്ല. You should have a proper timetable. So based on that timetable, you should run your studies. So you can complete mathematical physics by 3 or maximum 4 weeks. So if you are studying mathematical physics alone, you can complete it within 2 weeks. Maximum 2 weeks is enough. So if you're studying this mathematical physics with clubbing with two subjects, then you can take for a maximum of 4 weeks. Then next is ignoring transforms. So we will be studying well these vector calculus. We will be studying complex analysis. We will be studying differential equations. We will be studying all kinds of special functions like beta gamma functions, error functions, and so on. But we will ignore Fourier transform and Laplace transform. Fourier transforms and Laplace transform are sure short questions, and they could be answered without any uh, much thoughts. So they are more or less direct questions. So ignoring transforms is harmful. Should not do that. So you should study these Fourier and Laplace transforms with utmost importance. Then treating maths as a separate subject. No, mathematical physics is not a separate subject. It is imbibed in quantum mechanics. You can find it in classical. You can find it in electromagnetic theory. You can find it in you can find it everywhere. So it is not a separate subject. It has applications in each and every paper that you are going to study. So it is not a separate subject, and you should expect the question in that way. Okay. So നമ്മൾ മാത്തമാറ്റിക്കൽ ഫിസിക്സിന്റെ പ്രോബ്ലംസ് അല്ലെങ്കിൽ മാത്തമാറ്റിക്കൽ ഫിസിക്സ് മാത്രം പഠിച്ചിട്ട് പോയിട്ട് എക്സാമിന് വേറെ രീതിയിൽ ഒരു ക്വസ്റ്റ്യൻ കാണുമ്പോൾ we will get wonderstruck. What kind of question is this? So you should not get heart attack from in the examination hall. So നിങ്ങൾ പഠിക്കുമ്പോഴേ അങ്ങനെ പഠിക്കുവാണെങ്കിൽ it will be easy for you. Clear? Then come to classical mechanics. So classical mechanics is having a small syllabus, but it is having high conceptual depth. It is like mercury. If you mercury നിങ്ങൾ കാണുമ്പോൾ liquid mercury കാണുമ്പോൾ what it measures a little, but it is having a huge weight, right? So 500 milli of mercury may weigh to 2 kilogram for 3 kilograms. So just like classical mechanics, classical mechanics by just by naked eye it will be, it seems to have a small syllabus, but it is having inner depth. So what CSIR tests? So they will be testing about analytical mechanics. They will not test your memory. Okay, then they will test your understanding of formalisms, Hamiltonian and Lagrangian formalisms. Then you should be able to translate physics into equations. So there will be questions, there will be problems, that problems should be converted to equations. What equations? Equations of motion. Okay. So they will be given as you will be given a system. So that system should be converted into differential equations, and you will have to solve that differential equations. So that is what CSIR needs from you. And these are the high scoring topics from classical mechanics: Lagrangian formulation, then Euler Lagrangian equation, then small oscillation. That is what everyone ignore. Then calculating normal modes of motion, normal modes from applications of a small oscillation. Then Hamiltonian and Poisson brackets and canonical transformations. Then there is one addition for that. Addition to this, that is what special theory of relativity could also be tied up with the classical mechanics, even though it is somewhat different from this. Okay, so these are the high scoring areas that you should focus from this syllabus, and you should focus on doing problems. Then this is the strategy for beginners for classical mechanics. Then you should first focus on Lagrangian mechanics. So you should learn to write the Lagrangian. You should learn to formulate a Lagrangian from a given question. Okay, Lagrange's equation. You should write. You should learn to formulate, write the Lagrangian for a given system by reading the literature of that question. Then you should be able to write the Lagrange's equation of motion. You should be able to find out the cyclic coordinates, conserved quantities, all those things. Then you have to understand the concept of generalized coordinates and constraints. So there are many tricky and very confusing questions coming from these generalized coordinates and constraints. You should be able to answer those questions also. Then what you should focus? You should focus on simple systems repeatedly. നമ്മൾ എത്ര ചെയ്താലും we will be more familiar with the Lagrangian of simple pendulum, compound pendulum, double pendulum, then spring pendulum, all those things. We will be familiar with the Lagrangian of a simple harmonic oscillator, everything. പക്ഷേ when we are when we enter the examination hall, everything goes vacant. So നമ്മുടെ ബുദ്ധിയിൽ നിന്നെല്ലാം പോവും. So for as a remedy for that, you should solve simple systems repeatedly. Then you don't rush to Hamiltonian formalism initially. First, you should study Lagrangian mechanism, the constraints, generalized coordinates, all those related things. Then at last, go for Hamiltonian formalism. Then learn to convert Lagrangian to Hamiltonian, Hamiltonian to Lagrangian, all those things. The tricks are given in our classes. Okay. Then this is a strategy for repeaters. You should improve problem translation. So ഒരു പ്രോബ്ലം കിട്ടിക്കഴിഞ്ഞാൽ ആ പ്രോബ്ലത്തിനെ നമ്മുടെ മാത്തമാറ്റിക്കലി ട്രാൻസ്ലേറ്റ് ചെയ്യാൻ നിങ്ങൾ അറിഞ്ഞിരിക്കണം. So that's why you are a repeater now. So somewhere here or there we have failed in converting a problem to mathematical equation. So that is why we all are repeaters. So now in your next attempt you should improve your translation of a problem. Then you should practice identifying the cyclic coordinate, conserved quantities, etc. Then you should learn to solve part C problems only, because you are masters in part B problems, part B mode of problems. So you should learn to solve part C problems. Then you can combine, repeaters can combine mathematical physics and mechanics, especially you can combine differential equations and classical mechanics. Then you can solve for the equations of motion of Lagrangian formalism and Hamiltonian formalism. So those are differential equations, first order differential equations. So you should learn to find the solutions for that also. Clear? Given some initial conditions, you should learn to solve with initial conditions or boundary value problems. So you can combine those things. Clear? Then these are the common mistakes that we do in classical mechanics, memorizing the equations without their physical meaning. We will memorize what Lagrange's equation of motion. We will memorize Euler-Lagrange equation. We will memorize Hamilton-Jacobi theory. We will memorize the path integrals and everything. But you must not be knowing about you should not be knowing about uh, the physical meaning of those questions. So ആ ഒരു കാര്യം നമ്മൾ ഫോക്കസ് ചെയ്യണം. You should you should know about the equations with their physical meaning. Then ignoring symmetry arguments. Then skipping small oscillations. Small oscillations is very important. Small oscillations normal modes. So there, while studying small oscillations, the applications of our linear algebra, matrices, properties of matrices, properties of determinants, the applications of that comes in small oscillations while doing normal modes problem. So you can club small oscillations and linear algebra. So like that you should study. So ഇങ്ങനെ പഠിച്ചാൽ നമുക്ക് ക്ലാസിക്കൽ മെക്കാനിക്സും മാസ്റ്റർ ചെയ്യാം. Hope it is clear. Then if you have any doubts you may ask. Then quantum mechanics. Quantum mechanics is the king of CSIR net. So you should approach quantum mechanics with that due respect. Okay, quantum mechanics is not that easy, it's not that difficult. Okay, so what CSIR tests? So CSIR tests your operator thinking. So we are not uh, we are not thinking quantum mechanics in the way that we thought uh, in Newtonian mechanics or classical mechanics, right? So we are dealing the mechanics based on operators. So we should tune our brain in such a way that we are in resonance with the operator algebra. So then the conceptual clarity, the concepts of quantum mechanics, especially the formalism, then the principles should be very clear to you. So the conceptual clarity will be definitely tested. And mathematical handling of quantum systems, integration. Integration is the key. So you should learn integration. അപ്പോൾ നിങ്ങൾക്ക് ഇന്റഗ്രേഷൻ അറിയത്തില്ലെങ്കിൽ ഇപ്പോഴേ പഠിച്ചു തുടങ്ങുക. ഡിഫറൻസിയേഷൻ അറിയത്തില്ലെങ്കിൽ ഇപ്പോഴേ പഠിച്ചു തുടങ്ങുക. നമ്മൾ in CC what we do is first we will begin with the scratch. We will begin from teaching you differentiation and integration. Then only we will go for mathematical physics error analysis and such other things. So you should be well equipped with the mathematical basics or mathematical tools. So integration and differentiation should be brushed up. I hope it is clear. These are the major topics from quantum mechanics: operators, operator algebra, and commutation relations. Then eigenvalue problems. Then angular momentum algebra. Angular momentum algebra is very, very important, especially spin angular momentum algebra. Then you should not worry about calculating the Clebsch-Gordon coefficients, but that means addition of angular momentum. You should not be worried about. They are not that much asked. So, but you should be well knowledgeable about uh, spin angular momentum. So, spin angular momentum നല്ല ക്വസ്റ്റ്യൻസ്, നല്ല ഗ്രാവിറ്റി ഉള്ള ക്വസ്റ്റ്യൻസ് വരും സ്പിൻ ആംഗുലർ മൊമെന്റത്തിൽ നിന്ന്. നിങ്ങൾക്ക് അത് ചെയ്യാൻ കൃത്യമായിട്ട് അറിഞ്ഞിരിക്കുകയും വേണം. Then comes perturbation theory. Perturbation theory is very, very important. So time independent perturbation theory ആണ് നമുക്ക് വേണ്ടത്. ടൈം ഡിപ്പെൻഡന്റ് കുറച്ച് തിയറട്ടിക്കൽ ആസ്പെക്ട്സ് ഇപ്പൊ ചോദിക്കാറുണ്ട്. Then comes identical particles and basics of scattering theory. So these are the hot topics from quantum mechanics. Then this should be the strategy for beginners. So for beginners, uh, so beginners സംബന്ധിച്ചിടത്തോളം quantum mechanics will be a nightmare. So should not be like that. You should learn to love quantum mechanics. So you should first master the postulates of quantum mechanics. Then you should study the operator algebra. Then you should go for the measurements in quantum mechanics. How are we doing measurements? What is the significance of expectation value? What is the difference between expectation value and average value? How are you calculating these expectation values? All those things should be studied. Okay, so അതായിരിക്കണം നിങ്ങളുടെ studies. Then you should focus on one dimensional box problems very thoroughly. സോ ആ കാര്യത്തെ പറ്റിയും നിങ്ങൾക്ക് നല്ല അറിവുണ്ടാവണം. വൺ ഡയമെൻഷണൽ ബോക്സ് പ്രോബ്ലം, സോ ദാറ്റ് ഇസ് വെരി, വെരി ഇമ്പോർട്ടൻറ്റ്, ദാറ്റ് ഇസ് വെരി ക്രൂഷ്യൽ. സോ വൺ ഡയമെൻഷണൽ ബോക്സ് പ്രോബ്ലം നിങ്ങൾക്ക് അറിവുണ്ടാവണം, നിങ്ങൾ നന്നായിട്ട് പഠിക്കണം. ദെൻ യു ഷുഡ് ലേൺ ഓപ്പറേറ്റർ ഓൾജിബ്ര ആൻഡ് യു ഷുഡ് പ്രാക്ടീസ് പാർട്ട് സി പ്രോബ്ലംസ്. സോ I have given there simple part C problems earlier, and you should shift to difficult part C problems. So that should be your aim, beginners. Clear? Then what about repeaters? So repeaters in a they should focus on perturbation theory. So perturbation theory should be focused on. So perturbation theory is very, very important. Then you should focus on degeneracies. That means identical particles, degeneracy problems, then degenerate perturbation theory problems, and so on. Then selection rules. Their selection rules should be combined with atomic and molecular physics. Then you should improve operator manipulation speed. Operator algebra. അവിടെ ലീനിയർ ഓൾജിബ്രയുടെ ആപ്ലിക്കേഷൻ ആണ്. സോ ലീനിയർ ഓൾജിബ്ര ആൻഡ് operator algebra both are same. So you should focus on that. Then you should solve mixed concept problems. For example, scattering theory. That's very crucial. Then spin angular momentum, matrices, expectation values. All those will be mixed. So you should try to solve mixed concept problems. You should focus on doing so. Clear? So that should be the strategy for repeaters in doing quantum mechanics. And these are the common mistakes that you do. So treating quantum mechanics as a formula based paper, it is not like that. It is unlike mathematical physics. It's unlike it's not just similar to electromagnetic theory or statistical mechanics. It is different. It is based on concepts only. Then fear of operator algebra. Fear of operator algebra originate from linear algebra only. So you should get rid of that. Then skipping interpretation questions. Most 75% or three-fourth of the questions will be analytical interpretation type questions. So if you are skipping interpretation level questions, then you are skipping quantum mechanics completely. That means part C questions. So interpretation level questions നിങ്ങൾക്ക് സോൾവ് ചെയ്യാൻ അറിഞ്ഞിരിക്കണം. That's also very important. So you should avoid these mistakes while studying quantum mechanics. Hope it is clear. Then go to electromagnetic theory. So electromagnetic theory, it is concept plus vector calculus heavy topic. So concept plus vector calculus. So ഇവിടെയാണ് vector calculusന്റെ application, complete application of divergence, curl and gradient will be here. So if you have any doubts, you may just go to Griffith, then you will understand what are these applications of del operators. So the CSIR test Maxwell's equations in different forms that I have discussed in our classes. Maxwell's equations in normal form, linear form, all those things. Then boundary value problems. That is very, very important. Then the physical interpretation of these Maxwell's equations and everything. Then comes these are the high scoring topics from electromagnetic theory. So electromagnetic theory, electrostatics with boundary conditions, very important. Then Laplace and Poisson equations. Then method of images and its related problems. Magnetostatics, electromagnetic waves, Poynting vector. Then I'm adding one more point. It is regarding waveguides. That's also important. Then this should be the strategy for beginners. For electromagnetic theory, you should strengthen your vector calculus first. You learn vector differentiation, del operators, okay, gradient divergence curl. Then you should visualize field lines symmetry for doing the problems from Gauss's law. Then you should practice drawing Gaussian surfaces, understanding Gaussian surfaces. Then boundary problems. Learn to do boundary problems. Then you should learn to calculate reflection, transmission coefficients and all those things. Then you should solve fewer problems but do the problems deeply. Beginners initially should not focus on more complex problems, should do problems but learn deeply. Clear? Then beginners, for repeaters, should improve your problem selection. So even though you may be a repeater, we will not be able to answer all the problems that are asked from electromagnetic theory. Okay, so you should select the problems wisely. Should focus on in method of images, electromagnetic waves and its properties. So if you are given if you are given what electric field, you should be able to find the magnetic field and so on. Then should reduce algebraic mistakes. That is what we all do here in electromagnetic theory. While we do complex algebra, we will definitely make mistakes here and there, which will result in negative marks. Clear? Should reduce algebraic mistakes. Then learn shortcuts by using symmetry. Learn shortcuts by using symmetry that we have discussed in our classes. Clear? Then these are the common mistakes: blindly applying Gauss's law wherever unnecessary. So we may think that this problem is based on the Gauss's law. That is due to lack of practice. So you should apply Gauss's law only wherever required. So unless required, if you apply Gauss's law for doing problems, since it is unwanted, it will result in undesired result. Okay, so blindly applying Gauss's law will not help us. Then weak vector calculus. If you are weak in vector calculus, go back, go for mathematical physics, take it up, study it once again. Then fear of boundary conditions and its problems. Nothing has to be done. Go back, revise it, do the problems, then come back. So these are the common mistakes. So you should avoid these all mistakes while you study electromagnetic theory. Then statistical mechanics. So statistical mechanics is tricky. It is high scoring once understood. But to understand statistical mechanics, it takes some time. It takes your patience. It tests your patience. So statistical mechanics is high school. Definitely, if you understand statistical mechanics, uh, you can do any problem. Clear. There are no chances that you will get a negative mark from statistical mechanics if you understand it properly. So if you take if you take pain to understand statistical mechanics, definitely you will be rewarded. So what CSIR does here? So your physical interpretation of a problem. So the problem will be just like an essay. So you should read word by word. You should understand each and every word. You should understand what the examiner has asked. So if you are able to interpret it properly, then you are halfway done. Then correct ensemble selection. That's also crucial while doing problems. Should understand whether it is canonical, microcanonical, grand canonical. Then thermodynamic relations. For example, Maxwell's equations should not get confused. Should not forget all those relations and thermodynamic potentials, the connecting equations. So interpretation questions. Question interpretation. Question interpretation വളരെ physical interpretation ആയിരിക്കും. ജിനു ചാക്കോ നിങ്ങൾ മീൻ ചെയ്തിരിക്കുന്ന interpretation, അതായത് സ്റ്റാറ്റിസ്റ്റിക്കൽ മെക്കാനിക്സിന്റെ ക്വസ്റ്റ്യൻസ് നിങ്ങൾ ഇന്റർപ്രറ്റ് ചെയ്യുമ്പോൾ അത് ഞാൻ പറഞ്ഞതുപോലെ ഇറ്റ് വിൽ ബി ഡെഫിനറ്റ്ലി ആൻ എസ്സേ ടൈപ്പ് ക്വസ്റ്റ്യൻ. വലിയ ക്വസ്റ്റ്യൻ ആയിരിക്കും. പാർട്ട് സിയിൽ വരുന്നത് വലിയ ക്വസ്റ്റ്യൻ ആയിരിക്കും. ആ ക്വസ്റ്റ്യന് നിങ്ങൾക്കിപ്പോ ദാറ്റ് ക്വസ്റ്റ്യൻ വിൽ ബി അബൌട്ട് ആൻ അൺഫെമിലിയർ സിസ്റ്റം. So you should read the question and you should interpret the question in such a way that you are able to formulate a partition function for that question. So once you are able to write a partition function for that question, you are done 75% of that problem. Then ക്വസ്റ്റ്യൻ്റെ ലാസ്റ്റ് പാർട്ടിലേക്ക് വരിക. എന്താണോ ചോദിച്ചിരിക്കുന്നത് അതിൻ്റെ ബൗണ്ടറി കണ്ടീഷൻസും ഉണ്ടാവും. അവിടെ കുറേ ബൗണ്ടറി കണ്ടീഷൻസ് ഒക്കെ കൊടുത്തിട്ടുണ്ടാവും. ആ ബൗണ്ടറി കണ്ടീഷൻ വെച്ചിട്ട് നമ്മൾ ആ പ്രോബ്ലം വീണ്ടും ചെയ്യേണ്ടി വരും. അപ്പൊ അങ്ങനെ വേണം നമ്മൾ ആ ക്വസ്റ്റ്യനെ അണ്ടർസ്റ്റാൻഡ് ചെയ്യാൻ. അപ്പോൾ അതാണ് ഞാനിവിടെ പറഞ്ഞ ക്വസ്റ്റ്യൻ ഇന്റർപ്രിട്ടേഷൻ എന്നുള്ള വാക്ക്. സോ ക്വസ്റ്റ്യനെ കറക്റ്റ് ആയിട്ട് അണ്ടർസ്റ്റാൻഡ് ചെയ്യുക എന്നുള്ളത് വളരെ ഇമ്പോർട്ടൻ്റ് ആണ്. അവിടെയാണ് സ്റ്റാറ്റിസ്റ്റിക്കൽ മെക്കാനിക്സ് നമ്മളെ എല്ലാവരെയും കുഴപ്പിക്കുന്നത്. അപ്പോൾ സ്റ്റാറ്റിസ്റ്റിക്കൽ മെക്കാനിക്സിന്റെ ക്വസ്റ്റ്യൻ മനസ്സിലാക്കണമെന്നുണ്ടെങ്കിൽ നമ്മൾക്ക് നല്ല ക്ഷമ വേണം. ഓരോ വാക്കും എടുത്തെടുത്ത് വായിച്ച് 2, 3, 4 തവണ repeatedly you should go through that question, and then only you can understand that question and interpret it properly. Clear that these are the high scoring topics. Okay, the ensembles, microcanonical, canonical and grand canonical ensembles, then partition functions for grand canonical and canonical ensembles, then quantum statistics, classical statistics, thermodynamic identities, fluctuations. All those things are very important in statistical mechanics. Hope it is clear. Then this is strategy for beginners. So you should understand what is an ensemble and why is it important to have these much ensembles. Then should practice and practice. So that is what I have given here. If you are able to write the partition function for a problem, you can do anything and everything. Okay, so you should be you should practice in such a way that you are able to write the partition function of any complex question that is given. Then avoid memorizing every problem. Okay, no problem will be repeated in CSIR. So no problem will be repeated except for mathematical physics. So statistical mechanics ആണെങ്കിൽ ഒറ്റ പ്രോബ്ലം വീണ്ടും ചോദിക്കില്ല. So there is no point in memorizing these questions. So what you have to understand is you have to understand the method of doing each and every problem. Clear? Then relate statistical mechanics to thermodynamics. So first study statistical mechanics, then go for thermodynamics. Then for repeaters, you should master derivations, shortcuts. then limiting conditions, doing problems based on the limiting cases. Then you should focus on conceptual questions from part C. Then practice thermodynamics and statistical mechanics mixed questions. Okay. Then these are the common mistakes: memorizing the formulas blindly, confusing ensembles. So while reading a problem, you should not get confused about the which ensemble has to be applied, which concept has to be applied. Okay, so you should have a clear-cut idea about the selection of ensemble. Then ignoring the physical meaning of a problem. Clear. So these are the common mistakes that we commit while doing statistical mechanics. So so generally, repeaters should analyze your previous attempts. Then you should improve your accuracy. You should analyze your previous attempt means that you should analyze critically why you have failed, what are concepts that you are unfamiliar, what are points that you have to go in deep. So your weakness, your strengths, all those should be properly analyzed. Then you should improve the accuracy of doing problems. Then you should more focus on part C. It's very, very important. Should not avoid. Then practice time-based problem solving. Then only you will be able to crack CSIR. Hope it is clear. Then repeater upgrade plan. You should strengthen your high weightage topics. So I have mentioned the high weightage topics in the slides before. You should strengthen all those topics. Then reduce silly mistakes due to your ignorance. Okay, due to your carelessness. So you should avoid these petty mistakes. Then improve your selection of problems, selection of questions. Then analyze each and every mock test that you are undergoing. Clear. So weekly we are giving you 2 mock tests. So you should analyze. We are giving you more chances of analysis. Okay. Then these are the preparation tricks. So dimensional analysis. So while doing problems, if you are stuck somewhere, if you got stuck somewhere, just compare the dimensions from LHS and RHS. Then you should not avoid the limiting cases in each and every problem. Then the symmetry arguments that are given in the problems, and also approximation methods. Approximation, not from quantum mechanics, approximation methods. There are many approximation methods in mathematical physics, in statistical mechanics. So that those could be combined with these limiting cases also. So അങ്ങനെ കുറേ അപ്രോക്സിമേഷൻസ് എടുക്കേണ്ടി വരും. ആ അപ്രോക്സിമേഷൻസ് ഒക്കെ നമ്മൾ അറിഞ്ഞിരിക്കണം. ക്ലിയർ. Then for effective practice, previous year questions topic wise solve ചെയ്യുക. Then you should maintain an error notebook, mistake notebook. എപ്പോഴും ഞാൻ പറയുന്നതാണ്, should maintain a mistake notebook. Then go through the tough problems again. Then you should track your progress regularly. നിങ്ങൾക്ക് തന്നെ നിങ്ങളുടെ പ്രോഗ്രസ് ട്രാക്ക് ചെയ്യാൻ പ്രയാസമാണെങ്കിൽ ഞങ്ങൾ നിങ്ങളെ ഹെൽപ്പ് ചെയ്യും. ഓക്കെ. ദെൻ മോക്ക് ടെസ്റ്റിനാണെങ്കിലും നിങ്ങൾ യു ഷുഡ് ടേക്ക് ദ മോക്ക് ടെസ്റ്റ് ഇൻ എ റിയൽ എക്സാം പോയിന്റ് ഓഫ് വ്യൂ. ദെൻ അനലൈസ് മോർ ദാൻ അറ്റംപ്റ്റ്. സോ നിങ്ങൾ അത് ചുമ്മാ വെറുതെ പോയി അറ്റംപ്റ്റ് ചെയ്യുന്നു എന്നതിനേക്കാൾ ഉപരി മോക്ക് ടെസ്റ്റുകൾ അനാലിസിസിനുള്ള ടൂളാക്കി എടുക്കുക. Then only you can track the progress. Then improve accuracy and speed. അപ്പോൾ നിങ്ങൾക്ക് അക്യുറസിയും സ്പീഡും ഒരേപോലെ പോകണം. സ്പീഡ് കൂടി തെറ്റിക്കുന്നു എന്ന് പറയുന്നതിൽ അർത്ഥമില്ല. ഇറ്റ് ഇസ് മീനിങ്ലെസ്. You should improve accuracy and speed parallelly. Then adjust the strategy accordingly. So by analyzing the mock test, you can you can test the strategy. So likewise you have to adjust the strategy. Okay, നിങ്ങൾക്ക് അഡ്ജസ്റ്റ് ചെയ്യേണ്ടത് നിങ്ങളുടെ പേഴ്സണൽ ആയിട്ടുള്ള കാര്യങ്ങൾ നിങ്ങൾ അഡ്ജസ്റ്റ് ചെയ്യുക. ക്ലിയർ. ദെൻ സോ CSIR NET ഇറ്റ് ഇസ് ലേണബിൾ. അത് ഞാൻ മുമ്പേ പറഞ്ഞതുപോലെ, നമ്മൾ പല വീഡിയോയിലും പറഞ്ഞിട്ടുള്ളതുപോലെ, ഇറ്റ് ഈസ് നോട്ട് ഓൺലി ഫോർ ഇൻബോൺ ഫിസിക്സ് ടാലന്റ്, it is only for hard working people. Then failure, it is not an end, it is only a feedback. So smart work works better than hard work. So do hard work in a smart way. That's what I suggest. Then consistency matters. ഇന്ന് പഠിച്ചു നാളെ പഠിക്കാതിരിക്കുന്നു, ഒരാഴ്ച പഠിക്കാതിരിക്കുന്നു. നോ, എല്ലാ ദിവസവും ഒരേപോലെ പഠിക്കുക. Then ട്രസ്റ്റ് ദ പ്രോസസ്. എപ്പോഴും എല്ലാ കാര്യങ്ങളും ട്രസ്റ്റ് ദ പ്രോസസ്. നിങ്ങൾ പേടിക്കാതിരിക്കുക, ഫിസിക്സ് എൻജോയ് ചെയ്യുക, ഡിസിപ്ലിൻഡ് ആയിട്ട് പഠിക്കുക. അത്രേ ഉള്ളു കാര്യം. അങ്ങനെ പഠിച്ചാൽ ജൂണിലെ CSIR നിങ്ങൾക്കുള്ളതാണ്. സോ ഐ വിഷ് യു ഓൾ ദി ബെസ്റ്റ് ആൻഡ് ഐ വെൽക്കം യു ഓൾ to competitive cracker again. So we will meet you with